Visit www.ashbridgesbay.ca/BE-whiteboard for a navigable interface to all of our whiteboard drawings. Welcome to our whiteboard drawing, Jump to 9.1.2, Activities in Clusters. In this drawing, we'll describe the activities in the Jump Lab clusters. First, let's look at our production cluster, which uses the Production Collaboration VLANs. These are routed production VLANs. The current production VLANs for collaboration apps are Production Collab A and Production Collab B. We only need two VLANs if HA is required. If we don't need HA, then we can use a single VLAN. The production cluster has our MCS servers running earlier software. We're going to put the Cisco collaboration apps that will go on our first BE6000 server on the Collab A VLAN, and the Cisco collaboration apps that will go on our second BE6000 on the Collab B VLAN. We'll put the publisher and CUCM1A on Collab A, and our TFTP server and CUCM1B on Collab B. If we have a Cisco Unity connection deployment, we'll put the connection publisher, CUC1, on Collab B, and CUC2 on Collab A. The activities in our production cluster are: upgrade device loads to the target 9.1.2 loads. Cisco recommends upgrading device loads before upgrading the cluster. Patch freeze before installing the Builds cluster. Change freeze before migration of the production cluster configuration to the Builds cluster. Verify replication. It's unlikely that you'll have issues with replication, but it only takes a few seconds to verify, so we'll do it frequently. DRS backup to migrate the production cluster configuration to the Builds cluster. Inventory registered devices before cutover, and shut down. Let's take a moment to look at our production cluster for BE6000 deployments. We have two options. We have a small deployment and don't need a high availability solution, or we need a high availability solution. If we have no HA, we only need the Production Collab A VLAN. We'll put our CUCM and CUC publishers on this one VLAN. All of the services that we need will be activated on the publisher. If we have HA, we'll need both the Production Collab A and Production Collab B VLANs. Apps on the Production Collab A VLAN will be on our first BE6000 Enterprise 20 BE6KA. Our ESXi host corresponding to this server will be Enterprise 20 ESXi-A. Our CUCM publisher will go on Collab A. We'll put our Unity connection subscriber CUC2 on this VLAN as well. Apps on the Production Collab B VLAN will be on our second BE6000 Enterprise 20 BE6KB. Our ESXi host corresponding to this server will be Enterprise 20 ESXi-B. Our primary call processing server, CUCM1B, will go on Collab B. If we have a CUC deployment, our CUC publisher, CUC1, will be on Collab B, and the subscriber, CUC2, will be on Collab A. Cisco recommends that you do not put all of your publishers on the same server. Our CUCM publisher will be our backup call processing server and our primary TFTP server. CUCM1B will be our primary call processing server. This server will also be our secondary TFTP server. For this deployment, Cisco recommends all devices be registered to CUCM1B and the publisher be used as a backup. So we will have a single call manager redundancy group named 1B pub CMG that we will use for all of our devices. Why did we name CUCM1B 1B when we have no CUCM1A? Naming conventions help out a lot in the long run, but can be difficult to get right. We are using a convention where, as we grow, we'll deploy pairs of call processing servers. CUCM1A and CUCM1B, CUCM2A and CUCM2B, and so on. The A servers will be on the A VLANs and ESXi hosts, and the B servers will be on the B VLANs and ESXi hosts. We named CUCM1B 1B because it's on the B VLAN and B ESXi host. If we grow and add another call processing server, it will be CUCM1A and go on the A VLAN and the A ESXi host. This also keeps things consistent with larger deployments in the A-Bay labs. Our Enterprise 20 deployment is slightly more general to illustrate aspects of larger environments. We are using both the Production Collab A and the Production Collab B VLANs. Apps on the Production Collab A VLAN are on our first server, Enterprise 20 C220M3201. Our ESXi host corresponding to this server will be Enterprise 20 ESXi 221. Apps on the Production Collab VLAN will be on our second server, Enterprise 20 C220M3202. Our ESXi host corresponding to this server will be Enterprise 20 ESXi 222. Our CUCM publisher will go on Collab A. This will be our backup TFTP server. Our primary TFTP server, TFTP1, will go on Collab B. CUCM1A will go on Collab A, and CUCM1B will go on Collab B. Cisco recommends load balancing when using the one-to-one redundancy model. We will load balance using two call manager redundancy groups, 1A, 1B CMG, and 1B, 1A CMG. TFTP1 will be the primary TFTP server, with pub acting as backup TFTP. For our CUC deployment, our CUC publisher CUC1 will be on Collab B, and the subscriber CUC2 will be on Collab A. Cisco recommends that you do not put all of your publishers on the same server. The Builds cluster has the Builds Collab A and Builds Collab B VLANs. These VLANs are not routed to the production network. The Builds VLANs are for the installation and upgrade of the intermediate cluster. An intermediate Builds cluster is not required for migration from physical servers running 8.x, but we are using it to simplify the discussion of this case in conjunction with a jump upgrade and virtualization. The subnets used for the Builds Collab A and Builds Collab B VLANs will be the same as configured for the Production Collab A and Production Collab B VLANs. The Builds cluster mirrors the Production cluster. You must isolate the Builds Collab A and Builds Collab B VLANs. The Builds VLANs are carried on the trunks to the two ports on the LOM for the BE6000 medium density server C220 M3S SFF TRC2. These VLANs have no routed interfaces and only need to be configured on the two upstream switches. If you are not deploying HA and have only one server, then they don't even have to be configured there. The Builds VLANs will be enabled on the trunk. The Builds VLANs will have associated port groups configured on the host vSwitch 0. For C-Series with a quad gig E card, these VLANs will be on vSwitch 1. We'll add drawings for that as soon as we can. We'll distribute the collaboration apps across the two VLANs as in the production cluster. The activities in our Builds clusters are: install same software as in production cluster. If you are running version 4.x software, you will need to do a W1 upgrade using the DMA tool. DRS restore to migrate the production cluster configuration to the Builds cluster. Apply the refresh upgrade COP file. Upgrade the Builds cluster to 9.1.2. Verify replication. Do a DRS backup on the Builds cluster to migrate the configuration to the PreProduction cluster. Shut down. For an upgrade and virtualization from 8.x, the activities in our Build cluster are: install same 8.x software as in production cluster. DRS restore to migrate the production cluster configuration to the Builds cluster. Apply the refresh upgrade COP file if the software is earlier than 8.6. Upgrade the Builds cluster to 9.1.2. Verify replication. Do a DRS backup on the Builds cluster and rename the Builds cluster PreProduction and proceed to the cutover stage. The PreProduction cluster has the PreProduction Collab A and PreProduction Collab B VLANs. These VLANs are not routed to the production network. The PreProduction VLANs are for the installation and restore of the target 9.1.2 cluster. The subnets used for the PreProduction Collab A and PreProduction Collab B VLANs will be the same as configured for the Production Collab A and Production Collab B VLANs. The pre-production cluster mirrors the production cluster. You must isolate the pre-production Collab A and pre-production Collab B VLANs. We'll distribute the collaboration apps across the two VLANs as in the production cluster. The pre-production VLANs have no routed interfaces and only need to be configured on the two upstream switches. If you are not deploying HA and have only one server, then they don't even have to be configured there. The pre-production VLANs will be enabled on the trunk. These VLANs will have associated port groups configured on the host vSwitches. The activities in our pre-production cluster are: install the 9.1.2 publisher using the 9.1 OVA. Capture the device defaults. You need these long before cutover. These will be used to upgrade the devices in the production cluster before the cluster itself is upgraded. Install the remaining subscribers. Verify replication. Do a DRS restore to migrate the configuration to the pre-production cluster, and cut over. The jump server is a tool for providing a default gateway, routing, DNS, SFTP, and NTP to the isolated builds and pre-production clusters. Web access to those clusters is also provided here. The jump server has a VNIC on a routed enterprise network. Enterprise 20 puts the jump server in the jump lab. It's a virtual machine running on one of our BE6000s, and so the builds and pre-production Collab VLANs are accessible. You can access the jump server from anywhere in the enterprise via the routed enterprise network. There are other options for deploying the jump server. It could be anywhere in your virtual environment on some other production host. In that case, the builds and pre-production VLANs would need to be configured more widely. There's nothing wrong with doing things that way. The jump server has an additional 2 VNICs that can be connected to either the builds or pre-production VLANs. Enterprise 20 is using a Windows 2008 server. The jump server provides access into the Jump Lab environment, a default gateway for Collab apps, DNS, SFTP, and NTP for Collab apps. It could also provide SMTP. The jump server has no access to production Collab apps, production DNS, SFTP, or NTP servers used by the production Collab apps. You can add a virtual router to the environment, especially useful for HA environments to route between the VLANs in the builds and pre-production clusters. Why have both a builds and pre-production cluster? We want to have both of these clusters available simultaneously so we can compare and adjust as needed. This also allows us to work on these clusters in parallel. A complete guide for building a jump lab with a BE6000 and a Windows 2008 server is provided in our Jump to 9.1.2 playbooks. Thanks for watching!